Hey, Alexis. Eduardo, this is the second time you've tried to join my class. You were a little early last period. Your hair looks good today.
Oh, my hair? Oh, yeah, thank you.
You're welcome. No, I said you tried to join last period. I got a message you were trying to join the class.
Yeah, I got confused. My bad.
I feel you. I'm just marking away like everybody's here for sure. All right. Alrighty, so your test over this unit will be next Tuesday, and your journal test will be next Wednesday. So Monday will be your last journal for this 6 weeks. So the test on Wednesday will be over the notes that we're going to finish today, and also sick fix. It doesn't go back and do the other units. All right, if you'll open up your Chromebooks. I've got two.
On the Lowry, I found it.
Oh, good. Where was it?
In my backpack. I didn't look hard.
They're expensive to lose.
Is the test here?
Is it test what?
On here?
I get ready to be. Getting ready to be.
How's your day been, Miss Lowry?
It's been good, thank you. I'm ready for the week again. Let's try to stay up here and get all my work done, so I don't have to come up on Sunday like I usually do. Alrighty, there y'all go. It's open. You got 6. You have 6 minutes. Eduardo, you hear me?
What are we doing?
Yep, it's open. You got 6 minutes, and I'll cut you off. Be careful what you touch. Don't accidentally touch something or whatever, because it is what it is. The questions and the answers are all mixed, so it may not ask the question for your name until way down. Okay, so don't get it considers that a question. It mixes them all up.
We have to write the amount of numbers.
No,
We just write them in there.
you write the number. So if it's 3, you put a 3, not a TH or EE. Just a 3. Not any words. No words on these.
They're saying, do you have to put 0.4 or like 0.5?
You don't have to.
Just point.
Either way, it'll be correct if that's what's needed. As you know, with or without. Got about 2 minutes left. You got about 20 seconds left, so make sure you submit. Got about 20 seconds left, so make sure y'all submit. So if you did not do that, the last days to requiz will be next Tuesday and Thursday because it's closing out our first 6 weeks, believe it or not. Uh-huh. All right, everything that we're covering. Where'd you get that from? Okay, well, you might want to look at it. Did you look at what you picked up?
Yeah.
You think it had anything to do with what we're doing? Yes. Food webs. I probably like food webs better too. Why don't you put it back up for my next class? All right, so everything that we're doing today is stuff y'all have already learned before, except maybe temperature conversions. So we're just going to kind of refresh our memory. So the first one is doing metric conversions. Hold on, let me see if I'm getting this recorded because I'm tired of. All right. So remember, with metric conversions, it's just a matter of moving your decimal. And that's what we're going to be looking at today. However many sig figs you start off with is how many sig figs you should have at the end of a conversion. So these are your little units, your little prefixes. Notice here is any base unit that does not have a prefix. So like liters, meters, grams are all in there. So if I'm going from a small unit to a large unit, if I'm moving this way, then my decimal also moves that way. And my number decreases. It's going to get smaller. If I'm starting with one of the large prefixes and I'm moving the other way, then my decimal is going to move to the right. And my number will get larger. It will increase. So each time you move between a prefix or from a base to prefix, each jump represents a move that your decimal makes. And you'll need to memorize this order, because whenever you have it on the test, you won't be given this little chart. So you'll have to know that. So you always start with what you're given. If it's a big G, it's giga. If it's a big M, it's mega. Milli is your little m, so you can tell the difference between those two. And then this little funny looking U, oops, right there, that's a micro. All right, so we're going to start with our first one, and I have 0.0075 gigameters. So that's going to be right here. And I want to convert that to kilometers. So I only need to move it 2 places. So I'm going to move my decimal that same way, and it's going to be 1, 2, and I would end up with 0.75 kilometers. Here I'm starting off with tetraliters, and I want to go to megaliters. My mess erased here. So here's my tetra, and I want to go to mega, so that's just 2 jumps. 2 jumps to the right. I move my decimal that same way. 1, 2, 0.091 megaliters. Y'all remember doing this before? No, but y'all have. I know y'all have. All right, my next one, I'm going from kiloseconds to centiseconds, so that's going to be quite a bit. So I'm going to go 1, 2, 3, 4, 5. 5 places, and once again, it's to the right. 1, 2, 3, 4, 5. So I would end up with 46 centiseconds. Started with 2 sig figs, and I still had 2 sig figs at the end. In fact, all of these, I started with 2, and I had 2 sig figs when I did my conversions. Okay, why don't y'all give the 6, so the next 2 lines, why don't you give those a try? All right, so let's look at this one. We're going from microseconds to hectoseconds. How many places do we need to move our decimal? 6, right? Because here is my micro. So 1, 2, 3, 4, 5, 6. 6 places, and I move it the same way that I'm making my jumps. So to my left, 1, 2, 3, 4, 5, 6. So I end up with 0.2444753 hectoseconds. All right, my next one, I'm going from megabytes to gigabytes. So that was just a little one place. One here, jumped once. So my decimal was right here, so I'm going to move it back one, and I would end up with 409.6 gigabytes. Here I went from hectometers to centimeters. How many places was that? 4. And we were going to our right. So that means I would have, here's my decimal, I would have had to move it 4 places this way, and I would have ended up with 2,100,000. All right, next one, micrograms to milligrams. How many places was that? Just one. So I went from micro to milli. So I got to back it up 1. 0.00002. Centigrams to grams. 1, 2. Because remember, this is all of my things, all of my bases that don't have any prefixes. So that was 2 places. So back my decimal up 2 places. 1, 2. 4.485. And then my last one, microliters to centiliters. So how many was that? Just 2. And just back my decimal up 2 places, just like we jumped. So I would have 0.0000034 centiliters. So that takes a little bit of practice. So try those at home this weekend, and then we can check them on Monday. Excuse me. There's a crack there. So the next thing we're going to look at is temperature conversions, which is probably one of the easiest conversions that we're going to do. My paper is typed a little bit different than y'all. So like y'all have these 2 on the very bottom of the page. So where this says 273.15, if you'll take that 0.15 out, and we'll just leave that at 273. So temperature conversions, Fahrenheit to Celsius or Celsius to Fahrenheit. If we want to get Celsius and we already have Fahrenheit, we would follow that formula. If I want to get Fahrenheit and I have Celsius, I would follow that formula. We don't really deal with Fahrenheit too much, so I'm not really going to go with that formula. If you need that whenever you get to work somewhere, then you can pull it back up on your phone and figure out your formula again. I do want you to notice that degrees Celsius and degrees Fahrenheit, but Kelvin does not have a degree sign. Also, Kelvin has no negative numbers in its scale. That's why scientists like it, because if they're using it then as some kind of formula, it doesn't cause it to change the sign, and they don't have to worry about taking the absolute value. So this is really more realistic of what we do, either going from Celsius to Kelvin or Kelvin to Celsius, and the conversion factor is 273, and that's 0.000 forever, like we talked about on our sig fig rules. So what that is saying is this 273 does not affect your sig figs. Your sig figs are always going to be dependent on what you're either adding to it or what you're subtracting it from. So if I want to get Kelvin and I have degrees Celsius, I add 273. If I already have Kelvin and I want to get degrees Celsius, then I'm going to subtract. So it's that easy. So we're not going to worry about these. So here I have 18.75 degrees Celsius, and I want to convert that to Kelvin, so I simply add 273. We're adding or subtracting, so we're looking at places behind the decimal. This has 2 places behind the decimal, so my answer should have 2 places behind the decimal. Oops, that should have been a 5. 7, 5. And then your units would be K. Same thing here, 88 degrees Celsius. I want to convert to Kelvin, so I'm going to add 273. 361K. And my last one, negative 20 degrees Celsius. Converted to Kelvin by adding 273, and I would get 253K. So probably the easiest conversion we'll do the whole year. If I had 253K and I want to get it back to Celsius, then what am I going to do? Just subtract 273. And then that would get me back to my degrees Celsius. All right, and then the last thing on our notes, which y'all have also done before, is scientific notation. So we're going to look at that. All right, so scientific notation is a shorthand way of writing really large or really small numbers. In scientific notation, a number is written as the product of two factors. So there's the coefficient part, there's the base, and then there's the exponent. And the base is always 10. So this will always be times 10 to some exponent. Your coefficient always represents your sig figs. So if I'm going to a standard number, this is a standard number how we're used to writing numbers. If it only has two sig figs like here, then when I turn it into scientific notation, it can only have two sig figs, or vice versa. If I have scientific notation and I want to go back to standard, I have to maintain the same number of sig figs. So if a number is greater than 1, you're going to move the decimal. A little bit of a typo here, so we're going to have to correct. You're going to move the decimal to the left until one non-zero number is in front of it. And then you're going to count how many places you moved your decimal, and that will be your exponent, and it will be positive. So if it's a really large number, it's going to be a positive exponent. The larger that positive exponent is, then the larger the number is. It is not just how many zeros that number has. Sometimes that works, but sometimes it does not. Slip a little bit. So like we looked at this one before, I started here and I start moving my decimal until there's only one non-zero number in front of it. So that would be right here. And whenever I counted up, I moved it 8 places. So that's where my 8 came from here. If the number is less than 1, so a decimal, then you're going to move your decimal to the right until you pass the first non-zero number. And now your exponent will be negative. And that negative exponent, that number besides the by the negative, will show how many places you move the decimal. And once again, it does not necessarily represent how many zeros you have. So over here, here's my decimal. So I'm going to start moving it to the right. 1, 2, 3, 4, 5, 6, 7. Till I move past my first non-zero number. So I have my 2.80. And then my exponent would be negative 7. All right, why don't y'all give those a try, these 6. I think y'all have a different one here than I have on my notes. So just by glancing at them, you ought to be able to tell which one's going to have a positive exponent or which one's going to have negative exponents. All right, what did we get for our first one? 45,000.
4.5 times 10 to the fourth.
Perfect. 4.5 times 10 to the fourth. And our 7 billion one?
7.07 times 10 to the
10 to the 8th. I counted 9. Let's see. Let's double count. 3, 4, 5, 6, 7, 8, 9. You had to move it 9 places to get 7.0.
Oh, okay. Yeah.
All right, what do we get down here? This, I don't even remember, that's tenths, hundredths, that I don't remember what. 0.00035. Who can say that in a real mathematical form? What does y'all help me? Tenths, hundredths, thousandths. What's after that?
10,000?
So that would be 3. I don't know.
3.51 times 10 to the negative 4.
Almost, except look, this would be a tricky one because those are my sig figs, so I would have to include that 0. If you didn't include that 0, it'd be wrong. This has 4 sig figs, so that had to have 4 sig figs. All right, what about this one? All those zeros in the 3.
3 times 10 to the negative 6.
That's right. Only 1 sig fig, so only need 1 sig fig. This one,
0.1 times 10 to the 9.
we wouldn't want it to be 0.1. We would want it to be 1. And I think this was what the other one was, right? I think I had mine. Yeah, that's what I heard after I couldn't figure out what was going on. So y'all had, it was all this, right? But you had not a period, a decimal at the end. So what would that one be?
Oh, those were sig figs.
Yeah, so this one really wouldn't be worth writing. Yeah, because I would have to rewrite. I'd have to give it all these zeros. 10 to the, how many places would I have moved it? 1, 2, 3, 4, 5, 6, 7, 8. I had to write all of those because they were significant figures, but I still moved my decimal 8. Not really worth writing that in scientific notation, is it? Yes. All right. So, y'all have done all of that. Already have. I think we got some aristocrats in here. Y'all are really selling those masks. All right. So if you will look in your Google Classroom. 7:38. Yep, y'all got about 10 minutes. So look at your Google Classroom. Is anybody having trouble joining? Did I have to share the code with anybody in here? Ashton, why don't you, if you look on your stream, I put that invite, and I think if you'll go in there and accept that invite, it'll get you into this class where I won't have to keep giving you the separate code, okay? I think everybody else was good. So if you go down to your classwork, under measuring matter mixed practice, this has density problems, making sure that you use the right number of sig figs. It has temperature conversions. It has metric conversions. Did that light just flash, or was that my imagination? It was my imagination, okay. It has everything that we've gone over. So this will get you ready for your test on Tuesday. Okay, so y'all got about 10 minutes or so, maybe a little less, to work some of these problems. All right, so Monday we'll actually start a new unit, but of course it won't be on the test. Don't forget journal test on Wednesday. Please do not get yourself caught off guard. And then we'll have our test over this unit on Tuesday. Probably do the Bunsen burner lab after the journal test, because the journal test doesn't take the whole period.